So this video is basically a correction of one of the homework problems. In section 2.4, it was number 14. So 2.4, number 14. Okay. So someone emailed me to ask about this, and we got on a Zoom call, and I was explaining how to do it. And he said, "Oh, well," and we talked about the reasons. And towards the end, he said, "Well, I tried putting that in, it didn't take it. The answer it takes is 1. So here's the problem." And there's some variability, but here's the version he got. So the limit as x goes to pi over 2 of e to the tangent of x power. And the web work accepts 1 as the correct answer, but it's not. So let's look at how would you solve this. So in order to solve this, I'm going to examine this function. I'm going to break it into pieces. So I'm going to write this as y equals e to the tangent of x. And this is basically something we've done already in class, but I'm going to show a different way to write it that maybe will be a little bit easier to follow, because this one is pretty complicated. I'm going to call this tangent x, I'll call that u, just some other variable. You could use z, q, p, whatever. Pick a letter. I'm going to use u. So I'm going to say that y equals e to the u power, because u is what I'm now labeling tangent x as. So then u equals tangent of x, all right? I've broken this composite function into its components, 2 pieces. We have an exponential function, we have a tangent function. Now, I'm going to draw the graph, or sketch the graph of each of these functions. I want you to think about, well, there's going to be a number of things, but I want you to think about the fact that this graph on the left, there was no x. Try to make it somewhat accurate. Yeah, good enough. My horizontal axis is the u-axis, and my vertical axis is the y-axis, because u is the input variable, so that's the horizontal axis, and y is the output variable, so that's my vertical axis. Okay, x is not necessary. X is not always the x-axis, or rather, the horizontal axis is not always the x-axis. So now, if well, let's do it like this. I'm going to center my graph in the most useful way possible. And the scale on these 2 graphs is not the same. So I'm not going to worry about labeling with numbers or anything. So tangent has an asymptote at pi over 2. So that vertical line there is at pi over 2. So then the graph, tangent, I'm kind of running out of room, but that's okay. We care about a little bit more graph. Fine, good enough. And this is at pi units. Okay. So if I am going to x, x is going to pi over 2 rather, the tangent function has an asymptote there, a vertical asymptote. So I can't just plug in. It doesn't work. E is a continuous function. So, normally, under certain conditions, you can switch E with the limit, apply the limit to the tangent, and let the E apply afterward. But only if the function E is continuous at the limit result for tangent. So if tangent of x was 1 or 2 or whatever, then we'd have e to the 1 power or e to the 2 power. That'd be fine, but we don't, because there's an asymptote. That limit doesn't exist, so e can't be continuous at that limit since it doesn't exist, right? There's an asymptote. Anyway, what we need to do is we need to apply a little bit of left-right analysis. What's the left limit? What's the right limit? So I want to look at what is the limit. Oops, change the pen here. What is the limit as x goes to pi over 2, say from the right, we'll do from the right first, it doesn't really matter. I'm going to say of e to the u. I could say of e to the tangent of x power, but you'll see why I do this in a second. So focusing on this graph on the right, if x is going to, oh, you know what, and I didn't label This is the x-axis, and this is the u-axis. The u is the vertical, because u is the output variable. So if I have x going to pi over 2 from the right, that would be from this direction. So I'm following this graph down. So when x goes to pi over 2 from the right, u, being the vertical coordinate, goes to negative infinity, because I have an asymptote and the graph is going down. So negative infinity. Now, I'm not going to say that this equals negative infinity. Definitely not. That's not what I'm saying. U goes to negative infinity. So I can switch the limit to say that u goes to negative infinity of e to the u. And I can say, okay, well, I'm dealing with what u is doing. So now I'm over here, since I have u as the horizontal here. When u goes to negative infinity, I'm following that graph out to the left. And the y-coordinate goes to 0. So that means I have 0. Okay? We've done this exact thing in class. We just didn't call it u. We called it x. So if you ignore all this and ignore all this and just focus on this, this is something we've already done. Okay? And then this we also did. It wasn't in class. It was an extra video. So we talked about this as well. This component here we talked about already. So what about the other direction? What about the limit as x goes to pi over 2 from the left of e to the u? Well, if we're going to pi over 2 from the left, that means from here. So we're following the graph up. So u goes to infinity. So I can switch the limit over to a u limit rather than an x limit. So this equals the limit as u goes to infinity of e to the u. That we've also done in class. This is infinity. And they don't agree. Since the two one-side limits disagree, I can conclude that let's change this. I can conclude that the two-side limit does not exist. So we did an example a little bit like this in class. It was different, but I think it's pretty similar, where you had to do the theorem didn't apply, switching the order of the limit with the continuous outside function, the e. That didn't work because I forget the reasons in that example, and here it doesn't for reasons we just talked about. And we had to check the left limit and the right limit, and I think in that one we got agreement, I suspect. I don't quite recall. Anyway, that's a clarification. So that WebWork problem had an error in it. I will see about correcting it, but in the short term, just here's the correct way to do that problem.